Here's number 31 from section 3.3. We're asked for the equation of the tangent line in slope-intercept form. So that's y equals mx plus b, or I think your book calls it y equals ax plus b. And we want to round the thousandths place on the a and the b pieces of that equation. So the thousandths place is 3 decimal places like always. And the reason we need to do that is because the function in question here is an inverse secant, and the place that we want to find the tangent line is at a 2. And so we're definitely going to have an irrational type of number on the slope and the y-intercept. So let's get started and recall that to write the equation of any line, we need both a point and a slope. The easiest piece to get is probably going to be the point. So we need to figure out the y value where x is 2 on the inverse secant function. So let's go to the calculator and see what we can do. And we probably run into the first problem here. There's no inverse secant button, and 1 over the inverse cosine is not actually equivalent to the inverse secant. This should give us an error. Yeah, it does. So that's not the same thing. If you'll recall from the videos or the notes, we have an identity here that's going to work out for us. The identity is the calculator conversion identity that says that the inverse secant of x is the same as the inverse cosine of the reciprocal of x, of whatever that inverse or whatever that input is. Take the reciprocal and then do an inverse cosine. So let's go back to the calculator. And let's try to find the inverse cosine of not 2, but of 1 over 2. This should be equivalent to the inverse secant. And it looks like we have a 1.047 if we round to the thousandths place. So let's put that in here. I'm going to change this to approximately 1.047. So there we have the point. We've got 2, 1.047. Next, let's get the slope. We know the slope comes from the derivative. So in this case, y prime is going to be, we got to remember the inverse secant derivative formula, and that will be a 1 over absolute value of the input times the square root of the input squared minus 1. So in this case, our input is 2. So y prime of 2 will be 1 over the absolute value of 2 times the square root of 2 squared minus 1. So this looks to me like it's going to be 1 over a 2 square root of 3. So again, we're rounding to the thousandths place. So in decimal form, let's go to the calculator and let's bring up a fraction. And we want 1 over 2 times the square root of 3. And in fractional or in decimal form, we're looking at about 0.289. So 0.289. So now we have the slope as well. Let's get into slope-intercept form, and we're going to begin with point-slope form. So the equation of the line is going to be y equals the slope, which is 0.289, times x minus the x value, which is 2, plus the y value, which is 1.047. And then to work this into slope-intercept, let's distribute the 0.289 so that we have y equals 0.289x minus, we need a 0.289 times 2. So let's go 0.289 times 2. That's a 0.578, so minus a 0.578 plus a 1.047. So now we need to take that 0.578, make it negative, add 1.047. So 1.047 minus 0.578, and we get a 0.469 there. So 0.289x, and that would be then plus 0.469 plus 0.469. There we have it, an answer for number 31.